Hi, welcome to my channel Mathemagic with Mohsin Raza. And today in this video we have to evaluate these finite sums that seems really hard and interesting. So before seeing how to solve these sums, please subscribe my channel for such an interesting and informative videos. So here how we can find the finite sums of them. We see that. So first sum is that they say that we have to find the summation of k equals to 1 to n k factorial times k. So we can write this sum to as this is summation k equals to 1 to n, and this is k factorial, and I can write this as k plus 1 minus 1. Okay, so if I multiply k factorial with this, what we get a summation k equals to 1 to n, and that will make it k plus 1 times k factorial minus summation k equals to 1 to n, and this is k factorial, and this actually is what? So this by definition of the factorial, this actually is k plus 1 factorial. Okay, so what sum makes will make be so it will be like k equals to 1 to n, and here that will be k plus 1 factorial minus k factorial. So here we recall one of the concept that's known to be the telescoping series, which says that if we have to find the sum of finite sum of the series of the form something like this is ai plus 1 minus ai, then what will be that? So you can see that if we plug in the values in it, so we get first thing, that is a2 minus a1, right? When we plug I equals to 1, then plus, then we plug I equals to 2, we get a3 minus a2, and then plus a4 minus a3, and so on. And in the last one it will be an plus 1 minus an, and you can see that a2 is cancelled with a2 in this term, and similarly a3 is cancelled with this a3, and similarly all of the terms will be cancelled, and we are left with what? We are left with an plus 1 minus a1. Okay, so by using this concept of the telescoping series, we can see that this is a telescope series, and we get what we get for this. We have to plug first n plus 1 in it, and because here you can see that here a n a k is what? A k is k factorial, so we have to plug n plus 1 in it, so we get n plus 1 factorial, right, minus, and we have to plug 1, so which is actually 1 factorial, and this says that the sum of the finite sum of the series which whose term is k times k factorial is n plus 1 factorial minus 1. Okay, so now we see the next one, which is this series, and by so to find the sum of this series, first of all we rationalize it, and by multiplying this k plus 1 k factorial minus k under root k plus 1 in the numerator as well as in the denominator, we get what? So in the denominator we have a formula which identity is that a plus b into a minus b, and we know that this is equals to a square minus b square, with a equals to k k plus 1 times k factorial k under root, and the b is k times k plus 1 under root. So by just plugging those values we get what? So first of all we can simplify the denominator, and what we get? So this is k plus 1 k under root whole square minus k under root k plus 1 whole square. Okay, so we have k plus 1 square times k minus k square into k plus 1. So first of all we take the common, which is k plus 1 here, and so we get what? So here we get k into k plus 1 minus k square. So k is also common, so k is common, so k into k plus 1, and inside we get what? We get k plus 1 minus k, and this will cancel out and we get 1. So eventually this is nothing but k into k plus 1. So we plug this in on the place of the denominator, and then the series will becomes what? So that series will be reduced to summation k equals to 1 to n, and in the numerator was that k plus 1 k under root minus k times under root k plus 1, and in the denominator we had this thing k into k plus 1, which gives what? This is giving us to k equals to 1 to n, and here if you divide this, then k plus 1 will cancelled out, and we end up with 1 over under root k minus, and here that will we are end up with 1 over k plus 1 under root. Okay, so if we take the negative to be common, so here that actually seems to be negative, summation k equals to 1 to n, and that is 1 over k plus 1 under root minus 1 over k under root. Okay, and we have seen that this is a telescope series that I have discussed in this video already, that if we have to find the summation I equals to 1 to n ai plus 1 minus ai, then this sum is actually nothing but a n plus 1 minus a 1. So by using this we get what? We get negative into here, that will be 1 over n plus 1 under root minus 1. So which is actually 1 minus 1 over n plus 1 under root, where n is bigger than 1, right? So this is our answer. So thank you for watching this video, and please subscribe the channel for more interesting and exciting videos. Thank you so much.